Hi, Assalamualaikum and a very good morning. So now we are in chapter 6, chemical equilibrium. And for now, we're going to look into the subtopic of 6.3, which is the Lee-Chatelier's principle. So in this video, we're going to learn about the statement of the Lee-Chatelier's principle, and we're going to apply this principle in order to explain the effect of the following factors on the system at equilibrium. So the factors includes the concentration of the reacting species, the pressure, as well as the addition of inert gases at constant volume as well as at constant total pressure. The other factors will include the temperature as well as the catalyst. So without any further ado, let us start with the subtopic of 6.3 first. So the Lee-Chatelier principle. So the Lee-Chatelier's principle is basically proposed by the Henry Louis Lee-Chatelier, which is a French chemist. So according to him, it was stated that when a chemical system is disturbed, it's gonna re-establish equilibrium by undergoing a net reaction that reduces the effect of the disturbance. So let's say if you have an equation that is at equilibrium, so let's say if you're going to disturb the equilibrium by increasing the concentration of B, then we need to get back to the equation in order to make it equilibrium again. So in order to make it at equilibrium again, after being disturbed, it needs to shift either to the right or to the left. And this will allows it to attain or re-establish equilibrium. Okay, and these are the factors that gonna affect the equilibrium position of a system. So the factors includes the concentration, the pressure, the adding of inert gases, and then we have the temperature as well as the presence of catalysts. For the factors of adding inert gases, we're going to look about that in two situations, in which the first situation happens at a constant total pressure, and the next situation happens when it at constant volume. So now let us look into the change in the concentration first, which is the first factor. So this equation here is basically at equilibrium. But now when you add your disturbance, which is adding Cl2, so your disturbance is you're going to add the concentration of the Cl2. Okay, so according to the Lee-Chatelier principle, we need to reduce back the concentration of our reactant. So we need to reduce it back. Okay, so the system will reduce the effect of disturbance by decreasing the Cl2 added. Hence, what we're going to do is that we're going to push the position of equilibrium to the right. Okay, because when we push it to the right, it will allows that the concentration of the Cl2 going to be decreasing because some of our reactant will be converted into product and hence will lower down back the Cl2 concentration. And as a result, the concentration of PCl5 going to increase. Meanwhile, the concentration of the other reactant going to decrease because it's going to react with the Cl here. Okay, so the position of equilibrium changes to the right. So we have the technique of DAPOE, DAPOE. Okay, so similarly, let's say if you have this equation and they are at equilibrium initially, but now you have the disturbance. So your disturbance is you remove or you decrease the concentration of your PCl3. Okay, so here is the disturbance. So according to the Lee-Chatelier principle, you need to increase back the you need to reduce the effect of disturbance by increasing back the concentration of the PCl3. And how can you do that? Okay, so the way that we can increase back the concentration of PCl3 is we need to shift the equilibrium to the left so that the concentration of PCl3 gonna get higher. Okay, so the position of equilibrium proceeding to the left, and as a result, the concentration of the PCl3 will increase similarly to the concentration of Cl2. And as a result, the concentration of the PCl5 gonna get lower. All right. And here are the summary for the change in concentration when it becomes a disturbance. So let's say you're going to increase the concentration of one of the product. Let's say if you want to increase the concentration of the C. So your disturbance here is the concentration of the C. Okay, So your action based on the Chatelier principle, you need to reduce it back. So how can you reduce it back? You can reduce it back by shifting to the left so that concentration of the C gonna be converted into A plus B. And as a result, the position of equilibrium gonna shift to the left. Okay, and you can try the others by yourself. Now we're gonna look into the second factors, which is the change in pressure. So the change in pressure only involves system with the gaseous component. And this is because liquids and solid are nearly incompressible and they have no relation with the pressure. So the change in pressure only involves system with the gaseous component. And the change in pressure can occur when we adjusting the volume. So according to the Boyle's law, when the volume decreases, then our pressure gonna be increases. So they are inversely proportional. Okay? And bila volume itu dimampatkan, there gonna be a higher collision of the number of mole of the gas molecule with the wall of the container. Okay? And that is why the pressure gonna get higher. And that is why the volume will be also be related with the number of mole. So we're gonna look about these two things in the next slide. So let's say if you have the changes in pressure. So the changes in pressure occurs when the volume is being decreased. So when the volume is decreased, okay, dimampatkan, the pressure will get higher. Okay, and according to the Chatelier principle, we need to reduce the pressure in order to reduce the effect. Okay, so our disturbance here is the increasing in pressure. So our action here is we need to reduce back the pressure so that it can get to the equilibrium. So how can we reduce the pressure? So the way that we can reduce the pressure is by looking at the number of mole. So in this equation here, we have 1 mole of the product, and in this equation here, we have 2 mole of the reactant. So 1 plus 1, we're going to have 2. So in order to reduce the pressure, we need to shift the equilibrium to the position at where the number of mole is lesser, so that the pressure gonna get slower. Okay, so we need to shift to the lower number of mole of gas component, and then therefore the position of equilibrium will proceed to the right. Okay, so when there is lesser number of mole, the pressure gonna get lower, which is what we wanted. Okay, so we know that the position of equilibrium going to the right, and as a result, the concentration of the PCl3 and Cl2 will get lower, and the number of mole here will get slower as well, because from 2 mole it's going to become 1 mole. But the concentration of the PCl5 will increase because the production will get higher. Now we're going to look into the next situation in which what we're going to do is we're going to increase the volume. So when the volume is being increased, we know that our pressure is being decreased. Okay, so when the volume increases, our gas pressure will immediately decreases. Okay, so here is our disturbance. And for our action, according to the Chatelier principle, we need to increase back the pressure. So how can we increase the pressure? We need to shift to the higher number of mole. So the higher number of mole here is at this position. So the position of equilibrium need to shift to the left. So we need to shift to the higher number of mole of the gaseous component, which is to the left. So by shifting to the left, we know that the concentration of our PCl3 and as well as the concentration of Cl2 will get higher. And as a result, the concentration of the PCl5 will get lower. Alright, so this is how the effects and the factors of pressure are dependent based on the Chatelier principle. And here are the summary of the changes of pressure. So now let us look into the equation here, which is at equilibrium. So we have the solid state, gases, gases as well as the gases here. So the number of mole on the reactant side is we have 1 mole. Okay, because only gaseous component can be involved in the pressure factors. The solid is ignored. Meanwhile, for the product side, we have 2 mole. So we have one here as well as one here. So let's say your change is the increase in pressure. So your disturbance is the increasing in pressure. Okay, and your action according to the Chatelier principle is you need to lower back the pressure in order to make an equilibrium. So how can you make the pressure lower? You need to shift at the lower number of mole, which is shifting to the left. Okay, so it need to side with the smaller number of mole. Okay, so you can try the other changes with the other shift by your own and try to convince yourself. All right. So now we're going to look into the next factor, which is the addition of the inert gases. So the effect of the addition of an inert gases to the equilibrium system can be studied based on these two conditions. So first at a constant total pressure, and the next one is at a constant volume. So now let us look into the first situation first, which is at a constant total pressure. So at a constant total pressure, the partial pressure for the reacting gases in the system are being lowered. Why is that? Okay, so you can imagine at the situation here. Let's say in a glass vessel, you have a molecule of A and a molecule of B. So the total pressure that we have at the initial stage, which is at equilibrium, is 10 atm. And now when we add inert gases, for example, helium, neon, xenon, and so on, into the system, the partial pressure or the total pressure here needs to be maintained because this is the situation. So when the pressure is being maintained, which is at 10 atm, somehow these reacting gases, which is A and B here, needs to be reduced, okay, in order to accommodate for the 10 atm. So let's say at initial stage, you have 6 atm here, and for PB, which is the partial pressure of B, you have 4. And therefore, your total pressure here going to be 10. However, when there is an addition of inert gases, let's say 2 atm, you know that the combination of PA and PB need to be 8 atm so that the PT can be constant, which is 10 atm. Okay, so that you can maintain the total pressure to be 10 atm. So somehow your PA plus PB here is reduced into 8 atm. Okay, just now is 10, but this both here gonna be 8. So it's somehow gonna be reduced. Let's say PA gonna be 5, and then PB gonna be 3, and then the inert gases, let's say 2 atm to be here. So somehow the reacting gases gonna be subjected to the lower partial pressure. Okay, so we can say that according to the Chatelier principle, addition of a normal gases at a constant total pressure, so total 10, dia masih maintain 10, it will subjected to a lower partial pressure of PA and PB, and hence we need to shift the equilibrium to the higher number of mole. So let us look into the example. So let's say if you have the example here, which is the PCl3 gases plus Cl2 gases in order to produce PCl5 gases. So let's say if you want to add inert gases at a constant total pressure. Okay, so when you add inert gases at a constant total pressure, your reacting gases, which is A and B, PA and PB, will get reduced. Seolah-olah partial pressure akan berkurangan. So you can say that total gas pressure will maintain, which is 10 atm, but the partial pressure of reacting gases will get lower. Okay, so here are your disturbance, and your action is you need to increase back the pressure. So how can you do that? So you can do the increase of pressure by shifting to the higher number of mole of the gases component. So you know that on the reactant side, we have 2 mole of gases, which is 1 and 1 here. Meanwhile, at the product side, we only have 1 here. So we need to shift to the higher number of moles so that our pressure can be increased. So we're going to shift the position of equilibrium to the left in order to increase back the pressure. And as a result, the concentration of the PCl3 as well as the chlorine gonna increase. And the concentration of PCl5 gonna decrease. Now we're gonna look into the next situation, which is at constant volume. So at constant volume, the total number of the gaseous molecule will be increases when the addition of inert gas is added. So let's say if you have an A molecule as well as the B molecule here. And now when we add gas C, which is inert gases, what we're going to get is that we're going to have A, B, and C. And as a result, our total pressure here going to get higher because PA plus BB plus PC according to the Dalton law. So our total pressure here going to get higher. Okay. However, the partial pressure of A and B will remain unaffected, unchanged. So, pada mulanya, concentration of A may be 6 and concentration of BB going to be 4. And then, let's say if you are adding inert gases, which is 4, the total partial pressure here will be increased by 14. However, the PA is still maintained to be 6, and then the PB will still maintain as 4. So, the pressure remains unchanged. So you can say that the total pressure sememangnya akan meningkat. Tetapi the partial pressure of each gases in the equilibrium system remains unchanged. And as a result, the addition of the inert gases at the constant volume has no effect. Okay, dia tak ada effect terhadap equilibrium position and also to the composition of the equilibrium mixture. So there is no effect for the equilibrium shift. Okay. Now we're going to look into the next factor, which is the factor of the temperature. So the change in temperature will alter the value of K, where K here refers to the equilibrium constant. Before this, you have looked about the change in the concentration or the change in pressure. And these two changes will not affecting the value of Kc after the equilibrium is established. However, for the effect of the temperature, the value of Kc gonna be affected. Okay, and this is something that you should know at this stage. And if you were to look at this equation here, we have our PCl3 gases reacting with the Cl2 gases in order to produce the PCl5 gases. And delta H here refers to the enthalpy, and it's also representing the heat change, perubahan haba. Okay, and the negative signs here refer to the exothermic reaction, in which it means the heat is being released. So if we were to read from the reactant to the product side, we know that the whole reaction is a exothermic reaction. And it's basically depending on how we write the equation. So let's say if I were to write the equation to be like this, which is reactant into the product, I know that my forward reaction is like this, which is I have a value of delta H is equal to negative 111 kilojoule. So my heat change here is a negative value. And this negative value refer to the exothermic reaction in which it stated that the heat is being released. So the easier way that you can look about this is to look at the EX here. So EX here refers to exit, which is keluar, and dia akan mengeluarkan haba. And since it's gonna release heat, so heat gonna be at the product side. Okay, but now if you were to change the direction, for example, the PCl5 cases produce PCl3 and Cl2, then you're gonna get your delta H to be positive. So positive is referred to the endothermic reaction in which heat gonna be absorbed. Okay, since heat need to be absorbed, the heat gonna be at the reactant side. Okay, And we're going to deal with the change in the temperature according to the exothermic or endothermic reaction based on the example. Let us look at that. So let's say if we have our forward reaction here, which is like this, because we usually read from reactant to product to be delta H to be negative. So what will happen if we increase the temperature? So the first thing that first, we know that this reaction is exothermic in which it has a negative value. So it's gonna membebaskan haba. And haba gonna be at the product side. Okay? And for now, you have your disturbance. So your disturbance here is the temperature is being increased. So when the temperature is being increased, your heat will also be increased. So your action, according to the Chatelier principle, you need to reduce the heat or the temperature. So what you need to do is you need to shift the equilibrium position to the left in order for the heat to be absorbed and going to be reduced down to a lower temperature. And as a result, more NH3 going to be dissociated in order to form the nitrogen gas as well as the hydrogen gas. So these two concentration going to get higher and the concentration of NH3 going to get lower because it's shifting from right to left. Okay, how about the temperature is being decreased? So when the temperature is being decreased, our action here is we need to increase back the temperature. Okay, so let us look at the situation again. So now the heat is being decreased because the temperature is decreased. So we need to increase back the heat. So we can go and shift the equilibrium position to the right in order to increase the heat content. And as a result, the position of equilibrium will shift to the right in order to release more heat to the surrounding and increase back the temperature. And as a result, more NH3 molecule gonna be produced and the concentration of the hydrogen as well as the nitrogen gas gonna get lower. Now we're gonna look into the next reaction which involve endothermic reaction. So endothermic reaction means the forward reaction is a positive value. Okay, and it means that the heat is being absorbed and heat is on the reactant side. Okay, so if you have the situation here, which is your disturbance, is the temperature is being increased. It means that your heat content is being increased. But according to your Chatelier principle, your action is you need to reduce the temperature. So the way that you can reduce the temperature is you need to go to the right so that the heat can be converted into, all these things can be converted into the product here. So we need to shift the position of equilibrium in the direction to decrease the temperature. So the position of equilibrium will be shifted to the right in order to absorb the heat supply. And as a result, more NO going to be produced and the concentration of the N2 and oxygen going to be lowered down. Okay, how about the temperature being decreased? So let's say if you have a disturbance and then the disturbance here is the temperature is being decreased. So your action, according to the Chatelier principle, the temperature gonna be increased back. Okay, so let us look into the diagram again. So let's say if your heat content gonna be reduced. So the way that you can re you can increase back your heat is you need to go to the left hand side so the NO can be converted into this item on the left hand side here so that your heat gonna be increased back again. Alright, so we need to shift the position of equilibrium in order to increase the temperature, which is to the left. And we can shift the position of equilibrium to the left in order to release the heat supply. And as a result, more NO going to be dissociated and then the concentration of the nitrogen gas as well as the oxygen going to get higher. Alright, so these are the factors of the temperature according to the exothermic and endothermic reaction. Now we're going to look into the catalyst. So for catalyst is basically a substance that increases the rate of the reaction without itself being consumed. So a catalyst will changes the reaction rate but does not change the yield of the reaction product. Okay, catalyst ataupun pemangkin tidak akan menambah concentration produk ataupun reactant. Dia hanya mempercepatkan proses tersebut. And a catalyst will increase the reaction rate of both forward and the reverse reaction to the same extent. So the same equilibrium mixture is obtained faster. Therefore, we can say that a catalyst does not change the value of Kc and has no effect on the equilibrium position. Dia hanya mempercepatkan sahaja. Alright? And here are the factors as well as the shifting of the equilibrium as well as the changes to the value of K. So the concentration will shift the equilibrium. Same goes to the pressure, volume, and the temperature. However, the catalyst will not shift the equilibrium position. For the changes to the value of K, only temperature will change the value of Kc. Okay, so I think that's all for today's video. See you again some other time. Bye!